So this is using the table feature of the TI84, and we will jump into a quick example for attacking problems numerically. So let's say we have a random function that we care about. This could be an applied problem or just a pure algebraic or geometric problem. And we're being asked to create a table of values equally spaced by 0.5, 5, and 50. So what this is saying is, go ahead and input your function into the y equals, because this is the function we care about. Okay, so if we're creating a table, we need to feed it this formula and then tell it how to set up the table before we go there. So that's why we go to this table set menu here. And table start is saying what x value do you want to start at, or what time value, whatever it might be. So here it didn't tell us, so we'll just start it at 0. And this delta table means the change in the table or the change in the independent variable to scoot along, and then report out what outputs you get from those. So here we said we're going to do equally spaced by 0.5 and then 5 and then 50. So let's go ahead and do that. And it's set to auto reply with the output values, so we don't have to keep crunching it. We'll just generate it for us. So now we can head to the table. And so you'll see it started at x equals 0, went up by 0.5, 0.5, 0.5, etc. That's what that delta table means. And then here are the outputs that are paired with the input you fed the table, right? So we gave it the x's, and then it spits out the y's. So here you'll see there's an error at 2, because it's actually undefined at 2. But that's okay, and we'll actually explore that in problem number 2. But here, let's just go back and practice this, changing the spacing of the table set. Here, maybe we care about having values equally spaced by 50. Maybe it's something we're creating every 50 items. We care about the average cost, something like that. And now you'll see what changed, that the x values are going up by 50, and then the y's are being reported out. And then let's try one more time to see, being replaced by 5. Oh, I skipped over 5. Well, that's okay. Hopefully I didn't lose you there. But we can see what happens when we space it out by 5, 0, 5, 10, 15. And then the y's are corresponding to that. All right? So that's changing the delta table. That's changing the starting point. The y's are automatically generated. Now, there's different types of problems where we might not want an automatically generated table. We might want to input these values ourselves to try to figure out what's going on. So what I see, a lot of students will just like kind of set this up, and then they want to know what happens at 500, so they'll just scroll for 10 minutes until they get to 500. And that's really could be solved a lot easier by saying, well, start wherever, it doesn't matter, because I actually want you to ask me for the input and then tell me the output. So that's what this setup means. This kind of becomes nullified, and then we go to the table, you see it should be blank. So say I want to know what's happening around 500. Well, you can put in x equals 500 and get that value instead of scrolling all the way down. But for question number 2, this is a particular interest in pre-calc and calc, but we want to know when the function's approaching a value, when the input's approaching another value we have. So let's say x is approaching 2. So how would we do that? Well, with a table, it's kind of hard to do, because again, we could be scrolling. But if I'm approaching 2 with x, I could approach from the left with x equals 1.9, 1.99, 1.999, etc. And we'll see that y is getting more and more negative. It's actually heading towards negative infinity. And if I were to approach it from the right-hand side, so coming from the right of 2, we see it's actually shooting off and getting very, very high in the y direction. So this thing's actually blasting off to positive infinity. If we keep going, we'll see these values are getting bigger and bigger. So 2e to the 6 is, there's 6 zeros after that too. So it's getting huge. So that tells us something about this function. And again, the fact that it's asking us for the inputs and we're telling it makes this process a lot faster than scrolling by factors of 10. And then also of interest is to find out about the long run behavior of a function. So we might want to just figure out for question number 3, what happens when x gets huge. So we might start with x being 10 and then increase our inputs by factors of 10 to see what's happening when we get really, really big. And you might be seeing what's happening already. As x gets huge, y is starting to get closer and closer to 1. It's rounding it off because it can't fit it here, but it's getting closer and closer to 1. So this tells us about the long run behavior of this function. As x gets gigantic, y tends to settle out to some number. It doesn't always do that, but by using the table in this way, we're able to grab that information. So there are some limitations to this, but this is the general process, and I hope you found it helpful.